Hello, I am Sk Samrat. Today we derive the solution of the Einstein field equation, the Schwarzchild solution, the simplest solution of Einstein field equation. Now, the now the Einstein equation. Now the Einstein equation. Without Einstein equation, we assume that the pure gravity and without matter. Gravity is pure. Now the equation is r mu nu minus of g mu nu r equal to 0. Now multiplying by g mu nu, the metric g mu nu, then we have g mu nu r mu nu minus of g mu nu r equal to 0, and we have r minus 2r equal to 0 and r equal to 0. So the Ricci scalar should be 0. Now we have r mu nu equal to 0. Okay. Now for flat space-time metric, d square equal to c square dt square minus dx square minus du square minus dj square. Okay, it transform in it is a spherical polar coordinate, and we have d square equal to c square dt square minus dr square d theta square minus plus sine square d phi square whole. Okay, where in spherical polar coordinate g mu nu the metric runs from mu equal to t r theta phi. Now let consider we have something in any term for solution for Einstein field equation or any curved spacetime, something in dt, something in coefficient of dt, something in coefficient of dr, and something in coefficient dr dt, and d theta d phi. Okay, now we assume that, let's consider and assume that d square equal to alpha of rt c square dt square minus beta of rt dr square minus 2 gamma of rt dt dr minus delta of rt d theta square plus sine square theta d phi square. Okay, where alpha beta gamma delta are positive. Now redefining r prime equal to root of power of delta of rt we have. Okay, now another type of reference frame, for another coordinate of reference frame, d square equal to alpha of r prime t c square dt square and beta of r prime t r prime square d gamma of r prime t dt dr prime and r prime square of d theta square sin square theta d phi square. Okay, by suitably redefining beta and gamma, let now we have redefining beta and gamma, okay, beta and gamma redefining, and d prime equal to h of r prime of t alpha of r prime t dt minus h of r prime of t gamma of r prime of t dr prime. Okay, and h of r prime of t alpha of r prime of t dt and dt prime and h of r prime t gamma of r prime t dr prime. Okay. Now we have redefining this, and we have for prime coordinate t and r, d square equal to 1 divided h square of r prime t alpha of r prime t of dt prime square plus h square r prime t gamma square r prime t d r prime square plus 2h of r prime t gamma of r prime t dt prime dr prime minus of beta r prime t dr prime square minus 2 gamma of r prime t h of r prime t alpha of r prime t dt prime dr prime h of r prime t gamma of r prime t dr prime square minus r prime square d theta square sin square theta d phi square. Okay, now which can be written as after removing the prime coordinate, and now we introduce something new, a prime coordinate removing, and we have d square equal to f of r t c square dt square g of rt dr square minus r square d theta square plus sin square theta d phi square, where we require that f of rt greater than 0 and g of rt greater than 0, and the metric sign for metric signs plus minus 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 metric sign. Okay, the Lorentz metric sign we consider. Now if this is greater than 0, now we consider d a square equal to e to the power alpha of rt c square dt square minus e to the power beta of rt dr square minus of r square d theta square plus sin square theta d phi square. For this function and this function we consider exponential function, and we have with boundary condition alpha of rt and beta of rt tends to 0 as r tends to infinite. Okay, now this is the metric. Now this is the metric g denominator tt, g subscript tt. Now g subscript tt, we have g subscript tt, this is e to the power alpha of t c square, this is g subscript tt. Now we have c square e to the power alpha of rt, this e to the power alpha of rt c square, this is g subscript tt. Okay, and now g subscript rr, this coefficient minus of this coefficient minus of e to the power beta rt, this coefficient is called minus of e to the power beta rt, it is called g subscript rr, and g theta theta, as similarly this r square coefficient is this, and g subscript of phi phi is r square minus of r square sin square theta, this is. Now we have g superscript tt, the metric 1 per c square to the minus alpha of rt 1 g of rr minus e to the minus beta g of theta theta minus 1 per r square g of phi phi minus 1 per r square sin square theta g tr, and g rt g theta phi, and the combination of r and t r theta phi with along is 0. There are no other any combination of g rt g theta phi g phi theta and others. Okay, and here one thing you see, gtt is the inverse of gtt is the inverse of gtt. This is simple assumption, gtt is inverse of gtt. When we divided 1 by gtt, we get gtt of superscript. Okay, now let determine the Christoffel symbol. Christoffel symbol. First, the Christoffel symbol we should know gamma mu nu with ordinary derivative rho. Gamma mu nu comma rho half del mu g nu rho plus del nu g mu rho minus del rho g mu nu, and gamma sigma mu nu is g sigma rho gamma mu nu comma rho. Okay, now the non-vanishing Christoffel symbol we get gamma t t t gtt half del t gtt plus del t gtt minus del t gtt. This is the same and opposite sign, then this will be cancel each other. Okay, now we knew that gtt gtt is, we know that is gtt is gtt is, this is the gtt subscript gtt c square to the power alpha t, and superscript gtt is 1 part c square to the minus of alpha minus alpha. Now we put that value and we derivative with respect to time, and we get where we get alpha dot divided 2, we get alpha dot divided 2, where dot stand for differentiating with respect to time. Now as similarly we have gamma TRT equal to GTT half del T GRT plus del R GTT minus del T GTR. Now this is the same, this is cancel with each other, and del R GTT. Now GTT, we know that GTT is c square e to the alpha t, and GTT is superscript is 1 part c square e to the minus alpha e to the minus alpha. Then we have put that value, and we have alpha prime divided to, where alpha prime stand for differentiation with respect to r. Okay, now as similarly we derive another component of Christopher symbol gamma t rr, gamma t rr, gamma t rr. Now GTT half del r GRT plus r GRT minus del T GRR. Now GRT and GRT is no component on the flat metric. Then we have this is 0, this is 0. Now we have only del T GRR. Now GTT and GRR value, we have GTT and GRR value, GTT and GRR value, GTT and GRR value. We have it is the GTT value and GRR value, this is, and we put all them together. This is the put all them together, and we have 1 part 2 c square to the minus of alpha minus beta beta dot, or beta dot stand for derivative with respect to time. Now we have gamma RTT GRR del R del T GTR plus del T GTR minus del R GTT, where GTR the metric and the GTR metric is 0, there is no other component and the flat matrix. Then we have, now we put the value GRR, this value GRR, and the GTT value, this we put them all together, and we have c square divided 2 e to the alpha minus beta alpha prime, where alpha prime stand for differentiating with respect to r. Now gamma RTR, now GRR del T GRR plus del R GTR minus del R GTR, where GTR and GTR is also be 0, there are no other component in the flat matrix. Then we have minus e to the power minus beta del T minus of e to the power beta half. We put the GRR value and GRR value, this is the G superscript GRR value, and this is the subscript GRR value, and we have this is the metric, and this is the metric. We need this two metric, this metric and this metric, and put that value all together, and we have beta dot divided 2. Okay, where dot stand for the differentiating with respect to time. Now we have another Christopher symbol gamma RRR GRR half del R GRR plus del R GRR minus del R GRR. These two terms are equal term and with negative sign, then they cancel each other, and we have one term GRR half del R GRR. Now we put the metric value G superscript GRR metric is minus to the minus beta, and subscript GRR metric is subscript GRR metric is minus to the power beta. Now we have these two value put all together, and we have beta prime divided 2. Okay, now we have another metric gamma r theta theta, gamma r theta theta. Then we have GRR 1 divided 2 del theta g theta r and del theta g theta r minus del r g theta theta. We have, there are no any other metric component of g theta r and g theta r. We get g theta r and g theta 0 and del r d theta theta. Now GRR and g theta theta is the metric, and we put this value on together, and we have g theta theta, g theta theta and GRR. This is the g theta theta minus r square, and GRR this is minus to the minus beta. Then we all put together, and we have the gamma r theta is the metric in a Christoffel symbol, and we have r e to the minus beta. Now we derive another, we now now we derive another Christoffel symbol, gamma r phi phi, which is grr half del phi g phi r plus del phi g phi r minus del r g phi phi. Now this g phi r and g phi r, there are no other metric component term, then this should be 0, and the whole term is grr minus half of minus of del r g phi phi, and we put that two value g phi phi and grr, where this is the g phi phi, this is g phi phi, this is minus r square sin square theta, and grr is minus e to the power minus beta, and we all put together and we have minus r e to the power minus beta sin square theta. Okay, and another metric component g theta r theta, g theta theta minus of del r g theta theta plus del theta g r theta minus of del theta g r theta. Now there are no other component g r theta and g r theta, then it should be 0, and we have g theta theta equal g theta theta gunita 1 by the half g r g theta theta, and we put this value g theta theta value, g theta theta value minus r square, and g superscript theta theta value is minus of 1 per r square, and put them all together and we have 1 per r. The Christoffel symbol of g gamma theta r theta is 1 per r. Now another Christoffel symbol gamma theta phi phi is g theta theta minus half del phi g phi theta plus del phi g phi theta minus del theta g phi phi. Now there are no other component g phi theta and g phi theta, it should be 0, and we have g theta theta my half gunitak minus half multiple minus of g theta phi phi. Then we put the value of the matrix g denominator phi phi, g denominator phi phi, g denominator phi pi, that is minus r square sin square theta, and g theta theta 1 per r square we have, and we put them all together and we have minus of sin theta cos theta. Now another metric with Christoffel symbol g phi r phi, g phi phi half del r g phi phi plus del phi g r phi, and del phi minus of del phi g r phi. There are no other component like g r phi and g r phi, it should be 0. Then we have put the metric value g phi phi and g phi phi, we have this is g phi phi minus r square sin square theta, and g superscript phi phi minus 1 per r square sin square theta, and we have 1 per r. Now we have gamma phi theta phi, another Christoffel symbol g phi phi half del phi g phi phi plus del phi g theta phi and del phi g theta phi, okay, equal to cot theta. This is as similar, we have done that, and we put the metric value and we get cot theta. Now we derive the Ricci tensor. Okay, now we derive the Ricci tensor. We know the Ricci tensor is r mu nu equal to del rho gamma rho mu nu minus del nu gamma rho mu rho plus gamma rho gamma sigma mu nu minus gamma rho sigma nu gamma rho nu rho gamma sigma rho nu. Now rtt oma rtt del rho gamma rho tt del rho, this is rtt del rho gamma rho tt minus del t gamma rho t rho plus gamma rho sigma tt, and minus gamma rho sigma t gamma sigma rho t. We have this is the Ricci tensor rtt, and we have this is the term Ricci tensor term, and there is mu nu is tt. We derive the component of rtt component, of Ricci tensor. Now rho runs from T r theta phi and sigma runs from T r theta phi. Okay, the combination, we now rho and sigma combination, this is the 4 component and this is the 4 component, which combination is non-zero and does not cancel out and does not repeat. Then we have the component is rho equal to first combination, rho equal to T and sigma equal to T. When we put rho equal to T and sigma equal to T and with RTT, in the RTT, then we have all component cancel each other and we have 0 component of RTT. Now second combination, rho equal to R and sigma equal to R, the Ricci tensor RTT, the Ricci tensor RTT, then we have del R gamma RTT minus del T gamma RTR plus gamma RR gamma RTT minus gamma RTR gamma R RT. Then we have the Ricci component. Now we have RTT, we put the Christoffel symbol we derived earlier, this Christoffel with the Christoffel symbol, this Christoffel symbol, this Christoffel symbol, and this Christoffel symbol, and this Christoffel symbol, and this Christoffel symbol, and this Christoffel symbol, we put them all together, we derive earlier, and we have this term RTT equal to c square divided 2 e to the power alpha minus beta of r prime prime minus r prime square minus alpha prime beta prime minus a beta dot dot divided 2 plus c square divided 2 e to the power alpha minus beta alpha prime beta prime divided 2 minus beta dot divided 2 beta dot square divided 4. Okay, now the another combination, rho equal to r sigma equal to T, another combination, rho equal to r sigma equal to T, RTT. Now put del R gamma r tt minus del T gamma r tr plus gamma r tr gamma t tt minus gamma r tt gamma t r t. Now this term and this term, it's repeat in, we see in second combination, this term and this term will be repeated. Okay, but this term and this term will not repeat it, then we derive that and we put the Christoffel symbol and we have plus alpha dot beta dot divided 4, this term is alpha dot beta dot divided 4, this term is alpha dot beta dot divided 4, alpha dot beta dot divided 4, and this term gamma, this term is c square divided 2 e to the power alpha minus beta alpha prime square divided 2. Okay, now another combination, rho equal to T and sigma equal to R, and RTT equal to del T gamma TTT minus del T gamma TTT plus gamma TRT gamma RTT gamma TRT gamma RTT. This is the same component and which negative sign, and this each cancel each other, and we have these two component of Christoffel symbol. Now these two components are same and which negative sign, this the put the Christoffel symbol and we have these two components are same which is each other and cancel each other, then we have this combination is total RTT is 0. Now another combination, rho equal to theta and sigma equal to theta. Now theta with T, all component of Christoffel symbol should be 0. There are no other Christoffel symbol with combination of theta and T, so this should be 0. Now another combination is rho equal to theta and sigma equal to R. Now we have RTT del theta gamma theta tt, this combination with theta tt, this should be 0, and del T gamma theta tr t theta, this should be the theta t combination Christoffel symbol, this should be 0, and now we have gamma theta r theta and gamma r tt and minus of gamma theta r t gamma r theta t, this is the combination of theta t and this should be 0, theta t this should be 0, but this combination, but this the Christoffel symbol, two Christoffel symbol, this should not be 0, then we have 1 power c square divided 2 e to the power alpha minus beta and alpha prime, where prime stand for derivative with respect to x, with respect to r, sorry. 7 combination, rho equal to r sigma equal to theta, we have the Christoffel symbol del r gamma tt del t gamma r tr plus del r theta r del theta tt minus gamma r theta t gamma theta r t, which is the theta t and theta t. This is the Christopher symbol with combine of theta t, this should be 0, and this is the Christopher symbol with the theta tt Christopher symbol, this should be 0. Now we have the component of first and second term. This is the we have component, but this component should be repeat in two combination. Okay, now combination of 8, rho equal to phi and sigma equal to phi. Now all 0 when rho equal to phi and sigma equal to phi with combine with Christopher symbol with gamma t with time component, then which should be all Christopher symbol should be 0. Now 9 combination, rho equal to phi sigma equal to r, and rtt equal to del phi gamma theta rtt minus del t gamma phi tr plus gamma phi r phi gamma rtt minus gamma phi rt gamma r theta phi. Now here the phi combined with tt, this Christopher symbol should be 0, and phi t phi, this Christopher symbol should be 0. Now we have phi t and phi t, this Christopher symbol should be 0. Now we have only this Christopher symbol gamma phi r phi gamma r t t. Now we have 1 power r square, put the Christopher symbol on that, and we have 1 power r c square divided 2 e to the minus alpha e to the power beta, alpha minus beta alpha prime, where alpha prime stand for derivative with respect to r. Now the last Christopher symbol, rho equal to r and sigma equal to phi. The Christopher symbol should be rtt del r gamma rtt minus del t gamma tr plus del r gamma phi r and del phi gamma tt, which is this Christopher symbol should be 0. This is the phi and t combination Christopher symbol, and this is also the phi and t combination symbol, this should be 0. And these two Christopher symbol, this Christopher symbol and this Christopher symbol, this is the repeated in two combination. We should see that. Now combine, now the all Christopher symbol should be added and recall the repeating term. We have the RTT, the Ricci tensor with mu nu equal to tt, time component is minus beta dot dot divided 2 plus alpha dot beta dot divided 4 minus beta dot square divided 4 plus c square divided 2 e to the power alpha minus beta of alpha prime prime plus alpha prime square divided 2 minus alpha prime beta prime divided 2 plus 2 alpha prime divided r. Now as similarly we should derive the RR component should be 1 per 2 c square e to the power minus of alpha minus beta dot dot minus alpha dot beta dot divided 2 plus beta dot square divided 2 minus alpha prime prime divided 2 plus alpha prime beta prime divided 4 minus alpha prime squared by 4 plus beta prime by r. Now another Christopher symbol we should derive, and as similarly r theta theta e to the minus beta of minus 1 e to the power plus e to the power beta minus r alpha prime divided 2 plus r beta prime divided 2. Now r phi phi is sin square theta r theta theta, we know that. Okay, now rt we have beta dot divided r. Now the Ricci scalar we should derive, Ricci scalars we get g, we multiplied I mu nu to g mu nu and we get Ricci scalar, the all component multiply, and we have e to the minus beta of alpha prime prime plus alpha prime square divided 2 minus alpha prime beta prime by 2 plus 2 alpha prime divided r minus 2 beta prime divided r plus 1 power r square minus 2 e to the power beta divided r square minus e to the power minus beta minus alpha c square of minus beta dot dot minus beta dot square divided 2 plus alpha dot beta dot divided 2. Now the exterior solution of the Einstein field equation, we have r mu nu equal to 0. We have we assume that the gravity is pure and there is no matter field. Okay, now RRT should be 0, beta dot but divided R equal to 0. Now beta dot is 0, now which leads to the result that the function beta of RT depend only R. Here we have with the pure gravity without matter field. Okay, now RTT we have all beta dot is 0, then we have RTT c square divided 2 e to the alpha minus beta of alpha prime square divided 2 minus alpha prime beta prime divided 2 alpha prime divided r equal to 0, and r equal to minus alpha prime divided 2 plus alpha prime beta prime divided 4 minus alpha prime square divided 4 plus beta prime divided r equal to 0. Now theta r e to the minus beta of minus r e to the beta minus r alpha prime divided 2 plus r beta prime divided 2 equal to 0. Now r phi we know that sin square theta r theta theta. Now this is c square divided 2 e to the minus e to the power alpha minus beta. This is the exponential component and c is the velocity of the light. This should not be 0. Then we dividing rtt by 2, then by 2, and adding to rrr equal to 0, we get alpha prime beta prime equal to 0. This is the important Schwarzchild solution. Now alpha of rt plus beta of r equal to f of t. So alpha dot of f of alpha dot equal to f dot of t, then exponential that exponential this term, and we have e to the power alpha of t and e to the power beta multiplying to the e to the power alpha, then we take to the right hand side and we have e to the power minus beta f of e to the power a e to the power alpha of rt equal to the power minus beta multiple e to the power f of t. Now then the rr theta equal to 0, we know that, and 1 minus e to the power beta minus r e to the power beta prime equal to 0, multiplying by this e to the power minus beta, and we have simple mathematics calculation and differential calculation. We have d power d r e to the power minus beta equal to 1, where beta depend only r. We see earlier we have integration. Now we integrated that term d of r e to the minus beta integration of dr, and we have r e to the minus beta r plus a, where a is the integral constant and e to the minus beta equal to 1 plus 1 a divided r. This is the important exponential e to the minus beta. Now e to the power alpha of rt equal to e to the power f of t of 1 plus a per r. Now we have soluting the Einstein field equation, and we have the metric in the curved space time. We have the new type of metric. This is d square equal to e to the power f of t c square 1 plus a per r dt square minus 1 plus a divided r of inverse of that, and dr square minus r square d theta square plus sin square theta d phi square. Now we already reached at that point. Now we assume t tilde equal to e to the power f of t divided to dt. Now dt tilde equal to e to the power f of t divided to dt. This is, we assume that, and we have just our metric so simple, then we assume that, and d square equal to c square 1 plus a per r d tilde square minus of inverse of 1 plus a per r d r square minus of 1 square d theta square plus r square d sin square theta d phi square. Okay, now we have what is the value of the a. This is our derivation thing. Now g00 equal to 1 plus square gtt. Now from the Newtonian mechanics we know that phi equal to minus a per t, where phi is the gravitational potential. Now a is, we derive a is, now we should know, and we know earlier that a equal to minus 2 gm divided c square, and put that value a on that metric, and we have dA square equal to c square 1 minus 2 gm c square r d tilde square minus of 1 minus 2 gm c square r inverse d r square minus r square of d theta square plus sine square theta d phi square. This is the solution, Schwarzchild solution of Einstein field equation, and this is the important solution, simplest and important solution. Okay, now here the concept of black hole. When r equal to 2gm divided c square, r equal to 2gm divided c square, then this term should be 0 and this term should be infinite. This is called the coordinate singularity. This is called and r is called Schwarzchild radius. When r equal to 2gm divided c square, this r is called Schwarzchild radius, and this is the event horizon of the black hole. This is the coordinate singularity. This is the concept of event horizon of the black hole. And when r equal to 0, when r equal to 0, we have, when r equal to 0, then we have r equal to 0, then this is the infinite and this is the 0, then we have the singularity. And what happened at the singularity r equal to 0, we don't know. This should be unknown. This is the concept of black hole, and we have this is the solution of the Schwarzschild solution of the Einstein field equation, and I think that helps.